Hello my dears, very good morning to all. So how are you all? I think you all are safe and fine. Okay. So in the last class we discussed about the power measurement of three-phase system using two wattmeters, and we discussed some conditions, right? We discussed some conditions of that two wattmeters, either one wattmeter reads 0 or both having equal value, or one is opposite value, like that. Okay. And we did some problems regarding how we can find the power of a three-phase system using a wattmeter, and how can we read the phase angle, how can we find the phase angle from phasor diagram in order to find the power, because power is nothing but voltage into current into cosine of the angle between voltage and current. So that phase angle is very important parameter here. So we did some problem regarding that. That's all for that session. So now we are going to discuss a very new session and very important session in circuit theory, that is nothing but two-port network. That is nothing but two-port network. So what is the meaning of a two-port network? See, two-port network. So what is the meaning of a two-port network? So two-port network means it having two ports. Ports in the sense it having one input port and it having one output port. One input port, it is called the port number 1. Port number 1, and output port is called the port number 2. So a two-port network is nothing but a network consists of two ports. Two ports mean two sides or two connecting points. One is in the input side and other is the output side. A simple example of a two-port network is that our transformer itself. See, our transformer itself. Transformer having one input port, right, in which we are giving the supply, and we are take output as the across the output terminal, two terminal, that is nothing but the output port. Like that in electronics, mainly in electronics, so many circuits are there. Filters are there, see, adders, subtractor, like that, in which there are only two terminal as input and two terminal as output is termed as the two-port network. A simple example is our transformer itself. That is a simple example. Okay, two wires can be taken to be as input and two wires to be taken out to be as an output. That is the concept of two-port network. So inside the two-port, this is one input voltage and there is one input current. This is output voltage and there is some output current. But inside that input, that means two-port network, so many complicated circuit will be there. So many interconnections of circuit will be there. This simply I drawn like a simple but a rectangle and a rod two-port network, but inside this two-port, no, it is very complicated. Different types of networks, different types of circuits, different interconnections, all will be there inside this two-port network. By peripherally seeing, it is simply a rectangular block and two-port network. That's why it is written a simple block with the two-port, because inside representation is very complicated. Okay, so we are going to discuss, actually this is all about the introduction of that two-port network. We are going to discuss about what are the different types of two-port network depending upon the two-port inside. Then this is one port and this is two-port. This is always same, no, there will be one input and there will be output. But the difference is that this inside, no, two-port network, this inside network, no, that may be vary. That may be vary. So depending upon that inside network, two-port networks named in so many manner two-port networks are named. So let's discuss one by one. What are the inside circuit and what its name, and how that two-port network, or why that two-port network is formed, or what is the peculiarity and what are the parameters and all. Okay, let's discuss one by one. So first we have to see First we have to see open circuit or impedance or Z parameter. Open circuit, impedance or Z parameters. Parameters are nothing but input voltage, input resistance, input current, input conductance, like that, no? Output voltage, output resistance, output conductance, no? Like that. That are all parameters. Voltage, current, resistor, all are parameters in electrical system. So let's see what you mean by open circuit or impedance or Z parameter. See, suppose this is V1 or V2 and Z11, Z12, Z21 and Z22, and this is I1, I2, I1 and I2. If a network is represented by, or a two ports network is represented by this equation, satisfying this equation. This is nothing but the voltage matrix. This is nothing but the impedance matrix, and this is nothing but the current matrix. Suppose a two-port network is represented by this form or this manner, then this is called the open circuit or impedance or Z parameter. Let's see one by one. Here, these equations satisfy, suppose these equations satisfy a given network, then we can write like V1 will be equal to Z11 I1 plus Z12 I2, and V2 will be equal to Z21 I1 plus Z22 I2. Let be equation number 1 and let be equation number 2. Okay, suppose I1 equal to 0. Let I1 equal to 0, then what happens means in this equation 1, suppose I1 equal to 0 means we can write like V1 by I2 will be equal to Z12. V1 by I2 is equal to Z12. And in equation number 2, if I1 is equal to 0, Z22 will be equal to what? Z22 will be equal to V2 by I2. Okay, so that is the condition for I1 equal to 0. Why I choose I1 equal to 0 means, as a condition means, in this equation the RHS is nothing but in terms of I1 and I2. So only way, and here also RHS is nothing but I1 and I2. So only way to find these Z11, Z12, Z21, Z22 all, in order to make this either I1 or I2 0 in equation 1 and 2, then only we can find. That is why I took first case I1 is equal to 0. So when I1 is equal to 0, I1 is equal to 0 is nothing but input is what? Open circuited, right? Open circuit. Only if the input port is open circuited, then only this I1 will be 0. Then only this I1 will be 0. So I1 equal to 0 means input is open circuited. And we got Z12 and Z22 from what? I1 equal to 0. I know this is a slightly complicated thing, I know that, but in maximum simple manner I am going to teach you all this, okay, in maximum simple manner, okay. So please keep patience, okay, until some problem we will do some problems, then only these things will be very, very clear to you, okay. So until then keep patient, okay. So I1 is equal to 0, and next condition is when I2 is equal to 0. When I2 is equal to 0, I2 is equal to 0 is nothing but what? Output port open circuit, right? Simply output is open circuit. Output is open circuit. Not mention this port and all, okay. Output is open circuited. So when I2 is equal to 0 in this equation, we will have Z11 will be equal to V1 by I1, right? V1 by I1. And when I2 is equal to 0 in the next equation, this Z21 will be equal to V2 by I1, correct? I1, correct. Okay. This Z11 is nothing but beta. This is V1 by I1 no. Z11 is nothing but V1 by I1 no. What is V1? Input voltage. What is I1? Input current. So this Z11 is nothing but input impedance of the two-port network. Okay, and see Z22. Z22 is, see Z22. Z22 is nothing but V2 by I2. What is the meaning? Output voltage divided by output current. Just nothing but what? Output impedance. Okay, this all in what? Ohm, right? Ohm, because impedance is represented in ohm. And see one thing, Z12 is nothing but V1 by I2. That means the ratio of input voltage to the output current. The ratio of input voltage to the output current. Source to what? I mean excitation to response, right? The ratio of excitation to response, right? That is why this Z12 is called transfer impedance. Transfer impedance. Okay, and similar manner Z21 is equal to what? Z21C. Z21, where is Z21? Yes, V2 by I1. Output voltage by input current. That means something which is connected to output and input. That means there will be a path to know. There will be a path, no. Then only that output and input will be connected, no. That is why the term transfer impedance came. Transfer impedance came. So Z21 is also called what? Transfer impedance. Transfer impedance. Clear? So we can say our open circuit or impedance or Z parameter. Why the name open circuit means? See, I1 is equal to 0, we are open circuit no. I2 is equal to 0, we are open circuit no. Only under the open circuited condition, these parameter can be calculated. Input impedance, output impedance, transfer impedance, all like. And what is the significance of this type of network in our electrical and electronics engineering? See, any system or any network can have some input impedance, right? Have some output impedance, right? Definitely there will be some interconnection between input and output impedance, right? That's all. That is the important. So any system in electrical or electronics can be represented like Z parameters. Z parameter. There will be some input parameter, there will be some output resistance. No, that is why this parameter is very much important. This parameter is very, very important. So that's all about this open circuit or impedance or Z parameters. Okay, and normally Z parameters are solved by T network. Make it as a heading, make it as a heading, and I will tell. What do you mean by T network? This is called the T network. That means, is there no similar thing you seen anywhere, right? In transmission line, no. In transmission line, this can be this short transmission line, I think not short transmission, it is actually medium, right? Medium transmission line. So medium transmission line, you can represent some input impedance and some output and one shunt impedance also. Shunt capacitance, right? Now you already studied in your BTech classes. We will study in our power system in later. So okay, so normally transmission lines are represented by these type of T parameter. So until now, just focus on this thing. Transmission line is represented by T network. Okay, so Z parameters are solved by T network means from these, if you have a network in the shape of a T like this, then from this you can easily find the Z parameter. That is the meaning. That means if you have any complicated network in your hand, if you solved and if you reduced that network into the form of this T or into the form of this T shape, then it is very easy to find Z parameter from that. That means a very easy network to get Z parameter very easily is nothing but T parameter. I mean T network. Okay. Any other manner, whether it is pi or no, it may be some other form of network are there. It is difficult to find Z parameter if the network is not in the form of T bus until. Okay, that's all. So what is the peculiarity of this T parameter means only from that T parameter we can easily find the value of what? Z parameter. Only from T network we can easily find the Z parameter. That's all. So what will be the Z parameter from this? We will do that. So the Z parameter is nothing but, here I can write like the Z11, it is nothing but the input impedance, right? Input impedance. Z11 is nothing but adding these two, Z1 plus Z2, and Z12 is nothing but Z11 is adding this two, Z2 is nothing but this only, Z12 is nothing but Z2, and Z21 is also what? Z2, and Z22 is nothing but adding this two, Z2 plus Z3 bus. So that is the Z parameter from the T network. By doing some problems it will be very much clear to you. Okay, don't worry. So as of now please focus on this concept. Okay, so Z11 is nothing but adding this two, Z22 is nothing but adding this two, Z12 and Z21 is nothing but just take the middle value, that means Z2 value. Okay, that's all. So that is the Z parameter of a T network. Z parameter of a T network. I know it's slightly boring session because some complicated things are here. That's why you might feel like no, it's not interesting and all, but it's very difficult. I mean important. In examination directly you can ask what is the Z11, what is Z12, or simply some examination no, you can ask the value of what is the name of that is Z12. Z12 is nothing but transfer impedance. That type of question will be asked. So that's why it's very important. So that's all about Z parameter or open circuit parameter or impedance parameter, right? Next we have to say short circuit or admittance or Y parameter. Y parameter. Short circuit, admittance or Y parameter. If you have an equation like Y is equal to I is equal to Vy. Suppose you solved what? So many circuits, so many complicated network, and finally you arrived a matrix equation like this. This is called the what? Y parameter. This Y1, Y12, Y21 and Y22 all are called the Y parameter or admittance parameter or short circuit parameter. Clear? See, from this I can write like I1 will be equal to what? Y11 V1 plus Y12 V2, and let be equation number 2. And what is I2 here? I2 will be nothing but Y21 right? Y21 V1 plus Y22 V2. Let be equation number 3. And if you when V1 equal to 0, when V1 equal to 0, what happens? From equation number 2, when V1 equal to 0, this Y12 will be equal to what? I1 by V2. What will be I by V? It is ohm raised to minus 1 or more. Reversed form of or ohm is in inverted form is called mho. Ohm raised to minus 1. That is the admittance. Y is nothing but admittance. It is nothing but I by V. No, V by I is nothing but R, which is the impedance, and we represent it is ohm. But I by V is nothing but mho, MHO or MHO or MHO. And from equation number 3, when V1 is equal to 0, we got the value of Y22 as Y22 is nothing but I2 by V2. That also in mho, right? That also in mho. Next, when V2 equal to 0. When V2 is equal to 0, what happened? When V2 is equal to 0 in equation number 2, what happened? You will have Y11 equal to I1 by V1. I11 B1 is also in mho, no issue. And in equation number 3, when V2 is equal to 0, we should have Y21 is equal to I2 by V1. That also I by B form, that also mho. That also mho. Is it clear? So this is called the, why this is called the short circuit parameter? So V1 equal to 0 means making the input port short circuit, right? V1 or voltage is equal to 0 means anything which is short circuited is called voltage equal to 0. So V1 equal to 0 is the condition only which we got the value of Y12 and Y22. And another V2 equal to 0 means making the output terminal short circuited. Making the output terminal short circuited. So in both of the cases, in order to get the parameters Y11, Y12, Y21, Y22, we got normally what? We short circuiting the terminals. That's why it is called the short circuited parameter. And all the time it is admittance, no? It is admittance, no? In all, no, Y1, Y2, Y3, Y, all are admittance. That is why it's called admittance parameter. Or Y is nothing, simply Y parameter. That's all. Is it clear? And similar to that Z parameter, see, T network are easily solved by Z parameter, no? Similarly, Y parameters are solved by pi network. Y parameters are solved by pi network. That is, suppose you have a network like this. Suppose you have a network like this. This is the shape of pi, no? That is why it's called a pi network. Long transmission line, no? Long transmission line can be solved by this pi network. We will study later. Okay. So, so any network is in the form, suppose you reduce, if you have complicated circuit in your hand, so many complicated circuit in your hand, somehow you reduced that complicated network into pi, into this shape, Z1, Z2, Z3 in this shape. From this it's very easy to find a Y parameter. That means admittances, so many admittance, right? Input admittance, output admittance, transfer admittance. Same manner, no? This Y11, no? I1 by V1, it is called the input admittance, like input impedance. Similarly, Y122, no? I2 by V2, no? It is called the output admittance. Similarly, I1 by V2, no? It is called the transfer admittance. Y21, no? I2 by V1, that is also called the transfer admittance. So like in what Z parameter, we can find, if you have pi network in your hand, it is very easy to find it is very easy to find y parameter from this pi network. Y parameter from this pi network. That means y11 is nothing but z1 plus z2. y12 is nothing but minus z2. y21 is nothing but minus z2, and y22 is nothing but z2 plus z3. Bus. If you have a pi network in your hand, then it is very easy to find the y parameter from that pi network. y11 is simply adding this two, y22 simply adding this two, y12 minus of this, y21 minus of this. Bus. That's all. So how can we write in the matrix form? Y matrix is nothing but z1 plus z2 minus z2 plus z3. Is it clear? And one more thing, y is nothing but beta. Y is nothing but z inverse. Correct? Correct? So if you have a z matrix in your hand, then you can find its y matrix by simply taking the inverse of that matrix. Simply taking the inverse of that z matrix, you will find y matrix. Similarly, in vice versa, z is nothing but y inverse, right? Z is nothing but y inverse. That means in your hand, if you have a y matrix, then you can directly find its z matrix by simply taking the inverse. Right? Okay, and how can we find the inverse easily? I will tell you one example. Okay, how can we find the inverse of a matrix? Okay, it's mathematics actually, but we need here it is needed. I will tell. So trick to find inverse. Inverse of a 2 by 2 matrix, 2 by 2 matrix. Because there are 3 by 3 matrix also. There are also some trick, but we not needed. We maximum will face 2 by 2 matrix only. That's why. So trick to find inverse of a 2 by 2 matrix. See that. Suppose you have Z matrix as Z is equal to Z1, Z2, Z3 and Z2. Let it be Z11, Z12, Z21 and Z22. Okay, that is correct manner, Z22. Suppose I have Z matrix like this in your hand. If you want to find the inverse of this matrix, which is nothing but y, Z difference is nothing but y, If you want to find the inverse of the matrix, first step you have to find what? Its determinant. Find determinant. It's very easy, What is the value of determinant? Determinant del is equal to nothing but determinant delta or delta is equal to nothing but what is the determinant of this matrix? This into this minus this into this 9. So it will be Z11 into Z22 minus Z12 into Z21 is the what? Determinant, right? This is the determinant. That is the first step you have to find for inverse. And second step is nothing but cofactor matrix. Cofactor, not adjoint. Adjoint of a given matrix. Adjoint of a given matrix. How can we find the adjoint of this matrix? It's very easy to find the adjoint of a 2 by 2 matrix. That is nothing but adjoint of Z is nothing but beta. Interchange these diagonal elements. That is nothing but Z22 and Z11. Interchange these diagonal element and make the what? Sign change of this diagonal element, that is nothing but minus Z12 minus Z21. Finish. That's all for that adjoint of set. That's all for that adjoint of set. If you have determinant and adjoint, inverse is nothing but, the third step is inverse. Inverse is nothing but Z inverse is equal to adjoint of Z divided by determinant of Z. Adjoint of Z divided by determinant of Z. That is nothing but 1 by delta. That is, delta is the determinant, no? So 1 by delta into Z22 minus Z12 minus Z21 Z11. This will be the inverse of a given matrix. This is not this much complicated. Whenever we are dealing with some problems, no, it is very easy to find. Okay, I will explain, I will tell. So until then, please note this. So if you have Z matrix in your hand, you can find Y matrix. If you have Y matrix in your hand, you can find Z matrix also. And T network can be easily solved by Z matrix, and pi network can be easily solved. I mean, Y parameter can be easily obtained from a pi network. Z parameter can be easily obtained from what? T network. That's all. Okay. What is the time now? Let's check. Okay. So that's all about this Y and Z parameters. Okay. Let's do one problem, then only it will be very clear. Okay. Then only it will be very clear to you. Let's do one problem. Let's do one problem. Okay. Let's do one problem. Okay, write a question. Write a question. Find the, in your examination, this type of question you may expect, right? Find the Y parameter of a given network. Find the Y parameter of a given network. So this is the question. You may expect this question also, this type of question also in your examination, because it's actually a similar to a one-liner question. No need to calculate for a long time. It is very easy actually if you know the concept. So see, find the Y parameter of a given network. So now, as of now, we studied about Z and Y parameter, right? So we learned that Z parameter can be easily solved by T network, right? And Y parameter can be easily solved by pi network. But this is T network now. But we have to find Y parameter now. How can we find? First you have to find Z parameter and take the inverse of Z parameter, bas kadam khali. Is it clear? So first you have to find Z parameter, because in T network it is very easy to obtain Z parameter. If you find Z parameter from that T network, then you simply take the inverse, then you will get the Y parameter. Bas. So let's try for that. What will be the Z parameter here? Z matrix here. What will be Z matrix? You can directly write Z11. The first element is nothing but I will write Z11, Z12, Z21 and Z22. Correct? Is it correct? And what is Z11? You can directly find Z11. 1 plus 2. It is nothing but 3. Right? 3. And what is Z12? It is nothing but 2. What is Z21? It is nothing but 2 again. What is Z22? It is nothing but 2 plus 1. 2 plus 1, that is Z22. It is 3. So you have now Z in your hand. Then Y is nothing but Z inverse. How can we find the Z inverse? How can we find the Z inverse? So first, what is, you have to find determinant. First step is what? Find the determinant. What is the determinant here? 3 into 3 9 minus 2 into 2 4. It is nothing but 5. So 5 is the determinant. And next step is nothing but what? Find the value of adjoint set. Adjoint of set. How can we find the adjoint of S matrix? 2 by 2 matrix. Interchange this, right? Principal diagonal. This is called the principal diagonal. Interchange these elements. No, element is interchange means simply it is interchange. It's again this and change the sign of this diagonal. -2 -2 -2 -2 bus. So this is called the adjoint of set. And inverse is nothing but Y matrix, which is nothing but what? 1 by 5 into 3 -2 -2 3. Bus. So that is the answer. That is the answer. You can multiply 3 by 5 -2 by 5 -2 by 5 3 by 5 and all. You will get definitely. Okay. We will short for 3 by 5 is nothing but 0.6. 2 by 5 is nothing but 0.4 minus 0.4, again minus 0.4 and again minus 0.6 This is the final answer. This is the final answer. So this is nothing but find Y parameter. Bus. So this is all about the question. It is actually easy, but you should know the concept. But the thing is, you should know the concept. Then only this can be solved very easily. Is it clear? Okay. I think it's very easy problem, right? But you should know the concept. You should know the concept. Write another question. Find the set parameter in the given network. It's very easy actually. Bus. You have to find the set parameter in the given network. It's very easy, it's very easy. See, in your RRB JE or SSC JE like examination, there will not be asked a long type of problem. The gate like problem there will not be asked. They simply test your basic knowledge. That's all. They simply test your basic knowledge, not the deep knowledge. What deep knowledge you have, they don't test that. They simply test the peripheral idea or basic knowledge that you have. Bus. In any state JEE examination, RRB JEE or SSC JEE prelims, you may expect a question like that. Simply, you can check your previous year question paper. That all will deal 1 or 2 line answer. Bus. But the concept will be very, very important. You have to cover all the subject, all the concept, and then only the answerable, that question will be answerable. That is the difficulty we are facing in technical examination. They don't expect to solve for 2-3 pages or 1 or 2 pages and finally find the answer. It may be asked in gate like examination, but in gate like or ISRO, BARC like examination or very high standard examination, that type of question may be there. Very difficult type question may be there, 1 or 2 question may be there, but in normal state AJ examination, this is the maximum level you can expect. They will simply check your basic knowledge. Bus. They don't want, if you have a deep knowledge, they don't want to know if you have a very deep knowledge. They don't know that. They don't want. They have a basic knowledge base. He should know everything. That's very important. He should know the basics, but he should know everything. Everything means every subject, electrical, electronics, power systems, power electronics, machines 1, machines 2, etc. etc. That they are checking. Simple. Okay. So find the set parameter in the given network means very easy. How can we find the set parameter here? Z matrix is nothing but Z11 is nothing but these two, right? 6. Z12 is nothing but this, right? Z21 is nothing but again this, right? Z22 is nothing but simply add this, that is 5. If you don't know Z11 is this plus this, definitely in your examination this question will not be answered by you, right? Will not be answered by you because you don't know how to add this. This is somewhat advanced level, no? You have to think Z and Y connection, then only this will be solved. See, this all question will check only your basic knowledge, not your deep, very deep knowledge about, not a long derivation concept you have. No. That they don't want. They simply want your what? Basic knowledge. Okay, so that's all. Let me check the time. Okay. One more question I can now. Write a question. Write a question. Next parameters is actually T parameter or transmission parameter. Next parameter is nothing, I think it's third parameter, no? T parameter or transmission parameter. T parameters or transmission parameter. What is that? Let's see. That's all. Okay. If you have this is called the T parameter or transmission parameter. T parameter or transmission parameter. That means if you have a matrix equation like this, I think it's already, you heard about this. The other name of this is called the ABCD parameter. Other name of this is called the ABCD parameter or ABCD parameter. This is very popular now. This is very popular, very popular. So if you have some equation of metric equation like this, V1 I1 equal to ABCD and V2 in this form, then this is called the transmission parameter. ABCD and all this is called the transmission parameter. Let's see how can we find this transmission parameter. We can write this equation as V1 will be equal to A into V2 plus B into I2, correct? Let be equation number 1 and let be equation number 2. And similarly I1 will be equal to what, beta? C into V2 plus D into I2, right? Let be equation number 3. Let be equation number 3. So if you do, let V2 is equal to 0, when V2 is equal to 0, what will be this equation? Will become B will be equal to V1 by I2, correct? B will be equal to V1 by I2 in equation number 2, and similarly when V2 equal to 0 in this equation, you can write like I1 by I2 is equal to what? D, or D is equal to what? I1 by I2. D is equal to I1 by I2. V1 by I2 means its unit will be ohm, right? Its unit will be ohm, right? I1 by I2, no, there is no unit. There is no unit. It's very important. And when what should be 0 next time? I2, right? First you consider for V2 0 and next you consider for I2 0. When I2 is equal to 0, what we get when I2 is equal to 0? From this equation 2, when I2 is equal to 0, what I get? A will be equal to beta V1 by V2, right? A will be equal to what? V1 by V2 when I2 is equal to 0, and its unit will be what? No unit, right? No unit, right? And similarly, when I2 is equal to 0 in this equation when I2 is equal to 0, we have C is equal to what? C is equal to I1 by V2, right? I1 by V2. And its unit will be not in ohm but in mho. MHO, right? This is ohm and this is mho. I by B is nothing but admittance, right? So finally you have all values like A, B, C and D, in which A comma D having no unit. Very very important. A comma D parameter having no unit, because simply I1 by I2 ratio is 1 and simply V1 by V2 ratio is other. So it doesn't have a unit. And but B have a unit of what? Ohm, and C have a unit of mho. Very very important. Mho having C have a unit of mho. It's very very important. So that is called the ABCD parameter. That is called the ABCD parameter. Okay, so that's all for today. My battery is, unfortunately my battery is draining. I mean, it's switched off anytime. So that's all for today. Okay, we will continue our class on next day. Okay, on tomorrow. Okay, so until then, take care. Bye.